So first in the code, we need to define n as we have a n by n matrix, and then we need to process the input. So we need to read the number n in. So now we have n, and so we need a structure to store this n by n matrix. We can use a two-dimension arrays to save the numbers. So the row is an array, and then the column is another array. So the whole table is an array of arrays. And now, as this is C++, and now we know the size of the array is n, and as this n is ready and it's not static, so this array need to be dynamically created. As this is an array of arrays, so we need to declare it as pointer to pointers. We use A for array, and we need to request a memory from operating system, and we have the size of the array is n. So here we have the array of pointers, and for each pointer in this array we need to request memory also. So here we need a loop. So we need a loop n times. For each pointer we need to allocate n integers. And now this array is initialized, and we have the space in the array for the table, and now we can read in all the numbers in this table. So we still need a loop. So in the outer loop, this one, we go column wise in the table, and in the inner loop, this one, we go row wise. So in the outer loop, we got each row of numbers, and in the inner loop, we got each number in a row. And here we need to read in each number. And each number, when each number is read in, we need to put it in the array. The location is based on the two indexes. And now we have the array ready. Now we need to analyze the array. So first step, we need to find the smallest number in the array. It has to be one of the locations of top left, top right, bottom right, and bottom left. So we can check only these four numbers. We can go through the whole array to find the smallest one, but we don't have to. We can check only these four numbers to find the smallest one. So here first we declare I and j for the location to identify the smallest number, and then we check whether in the first row, the first number and the last number, which one is smaller. So if A0, so this is the first row, and then another 0 for the first number. Is it less than the first row and the last number? And remember, in C++, the index of an array starts from 0, so you cannot use the size as an index. The last element in the array, that the index of it is size minus 1. So if this is true, then we know the smallest number is at the left side, not the right side. So here we put j equals 0. And if this is not true, then the smallest number is on the left side. J equal. Okay, I said it wrong. If on the first row the left number is less than the right number, then the smallest number is on the left side. Otherwise, it's on the right side. And so this is to find if the smallest number is on left or right. And now we need to find if the smallest number is on top or bottom. So here we need to check 0 and J. We already know that the smallest number is on column J. And now we need to find which row the smallest number is, whether it's less than A on the n-1 row. So if this is true, then we know the smallest number is on top. And else, the smallest number is at the bottom. Okay. Now we have I and J to identify the location of the smallest number. And what we need to do now is, based on this location, which is based on the values of I and J, we need to go by different directions to print the numbers out. So first we check the location of the smallest number based on I and J. So if this is true, which means if I is 0 and J is also 0, that means the smallest number is on top left. So here we need to go through the whole table and print them out. But we need to start always from the smallest number. So we use x and y here for the index, as I and j are already used. As we go through this table, we need to print out each number. After we print out a number, and remember we need to print a space out so that the numbers are separated, or else you cannot read the numbers in the output. So we print an extra space. And so in this loop, in the inner loop, a row of numbers is printed. After we finish each row, we need to print a new line so we can get to the next row. Okay, so this is for the print of the table in the first case where the smallest number is at top left. And now we need to check if the smallest number is on top right. So first we need to check the top right, and the j can be 0. Bigger than 0. So here we basically need a similar structure of the first loop as in the process when the smallest number is at the top left. Remember, in this scenario, we need to go down first and then to the left. So here we need to use a different index. So here we need to go through column wise first. So this is for columns, and for columns we need to go from right to left, and this is for rows, and for rows we need to go from top to bottom. This is the process for the scenario where the smallest number is at the top right. And now we need to check if the number is at the bottom right. So when the smallest number is at the bottom right, we need to go to the left side first and then upward. So for bottom right, so here this is not right. For bottom right, this j is also bigger than 0. And for the loops, as they both bigger than 0, so each of them is starting from the last element and then to the first one. This is for bottom right, and now for bottom left. We don't have to put the condition here, as this is the only condition left. So here as the smallest number is on bottom left, we need to go upward first and then to the right side. So now we have all the conditions checked and the process there, and so and then the data is printed out, and now we need to do the cleanup. So remember here we requested memory the new operator, and now we need to clean them up to release the memory. Just like how the resource is requested, you have to do them one by one for the arrays in the array, and then delete the array. Okay, so this is the end of the program.